Hello everyone. I'm trying to explain you the X-propagation in Verilog or system Verilog design. So basically, whenever some variable in Verilog or system Verilog design is not defined, or our test bench is not driving any value to that variable, then the default value will be X, and that X is treated as 0 in the RTL simulation. I will show you as an example in one of the examples here. So you can see here, this is the top module. In this I have created this select a, b, y variables. These are all reg variables, and I'm initializing these variables with 1, 0, and I'm not initializing the select variable. And after 10 nanosecond I'm initializing select equal to 1, and that means select equal to X for the first 10 nanosecond, and after 10 nanosecond select is 1. Now the condition here, the always com, is something like this: if select is 1, then y equal to a, otherwise y equal to b. So if we do the normal RTL simulation, then for the first 10 nanosecond select is X, so it will go into this else. So select will be treated as 0 in the RTL simulation, and uh, y will be assigned with the b value, and whenever the select becomes 1, y is assigned with a. So let us run this and view in the waves. Okay, so if we look at this in waves, this is a, b, y, and select. Let me put y below select, and initially for 10 nanosecond select is as X because it was not initialized, and then it is 1. And in the RTL simulation, this is value is 0 and then value is 1. Now it may happen that this is in the RTL simulation, it is taking as a 0 value, but since it is not there and it is X, so in the real silicon it can have 0 or 1 value. And if it is 1 value at this time, then this value will be 1, y will be 1 in it from the starting itself. So this is a creating a serious RTL, this is hiding a serious RTL bug. So we should always check uh, if some input signals are initialized properly or not, or they are X or not. So if we do the normal RTL simulation, it may hide the design bug. So to fix this, uh, we have a different X propagation simulation in the cadence tool. Before discussing that, let us discuss one more scenario for the X propagation. Okay, so let us see in the top.sv there is a second scenario in which I have a clock reset, and there is a load and signal which I am not initializing, which will be X, and then new count. New count is F0, and reset and is becoming 1 after 20 ns, and clock is toggling. Now in this always FF block, so here it is written whenever reset is 0, that at that time count will be 0. When the load is 0, then the count will be assigned with the new count, and when load is 1, means in the else part, the count will be incremented. So in the same thing, let us see what are the values of clock, reset, load, and so clock, reset, load, and new count and count. So you can see here load n is X because it is not driven, and RTL simulation is treating it as this condition is 0. So it is X. So it is not going inside this. It is treating this as 0, and it is going in the else part. And it is because RTL is always checking whether load n is 0 or not. So it is not 0, it is not 1, it is X. So it is going in the else. So it is incrementing always. But in real simulation, not in RTL simulation, if it is 0, then it will get this value, new count value, which is f0. So it may happen that sometimes it can become 1, then sometimes it can become 0. So here the increment, if you see here, it is incrementing one by one, 1 2 3 4. But in the real silicon, it will be value like here, if it is 1, then it will be f0, then here it will be f1, f2. This way it can increment. Now to fix this problem, we are coming with means Cadence is coming with a X propagation simulation. So there are two types of simulation. One is cat and one is fox. So here is a Cadence article which tells that how X propagation uh, causes the problem. So to fix this, Cadence is coming with the X-prop analysis, and there are two modes by which we can do the X propagation simulation. One is compute as ternary and another is forward only X. So these two modes we will discuss here. So how to enable the forward only X or compute as ternary. So we need to create a X-prop file. So something like this, top.xprop file. Inside this we need to write the value here. So scope, then top, this is the top module name, and here is it is whether it is cat mode or fox mode. So here it is C, that means cat mode. If I want to change to fox, then it will be F. Then scope, then top, then three dots meaning it will apply to all hierarchy below top. And what will be applied? So it will be applied as F. So F meaning forward only X. And these two lines we need to include in this X-prop file, and this file we need to provide while running the X propagation simulation. So let me show you where we need to provide. So in this command we can write x file -x file and top.xprop, and then we can run the simulation. Okay, I forgot to save the file. Let me run again. Okay, so now if you see here, previous waves were this, that select was X and Y was treating select X as 0 and it was giving 0 out, and this load N was X and it was treating, it was not going in this condition, it was going in the else condition. So that is why count was incrementing every time at every passage of clock. Now if I reload this, then you can see here it is treating X as X. That means if it is X, then the output should be X only. It will not be anything else, 0 or 1. So whenever, if you see in this, if it is select is X, that means you cannot determine whether Y is A or Y is B. So Y will be always X in this case. Similarly, when load N is X at that time, so it is executing at the nagage of reset n. So nagage of reset n and then pausage of clock. So here count value will be X because it is not calculating, means it is not able to understand what is the value of load n. So X meaning the output of count will be always X. So this is forward only X mode. Now let us change this to compute as ternary mode. So we need to change F to C and here also F to C and save the file. Now we will again run the simulation with the same command, no change in the command. And let us look at the waves. Okay, so now it is treating it as a compute as ternary. So that means okay, let me show you the how it works, how it is different than the forward only X. So here you will not find any difference, it is same, but here you will find a little difference. Here it is XX. So if we expand this, then this 4 bits are 1 1 and this 3 bits are 0, and this is again, sorry, this 4 bits are x, this is 0 and this is x. Now how this is coming 0? So basically if you look at this condition, when load n is 0, that means it will take this value. If it is 1, that means it will increment the value. So at this time, if load n value is 0, that means it should take this new count value, which means f0. And if it is 1, then it should take the 0 1 value, because it should increment. New count value means the count value should be 0 1. And we need to see that what are the common in 0 1 and f0. So in 0 1, okay, let us write down here f0. If I put it in the binary, it is something like this, and 0 1, it is something like this. So in this, in the compute as ternary mode, it will check that how these two possible outcomes are there. If the both possible outcomes has the same value, then it will show here the same value. If they have a different value, then it will show here as a x. So first 4 bits are 1 0 1 0 1 0, that means it is showing x x x x. These 3 bits are 0 0, so it is showing 0 0, and here it is 0 1, so it is showing x. So that is why it is coming here is some bits are x and some bits are 0. So this is the difference between compute as ternary and forward only x. And if you see in the first case, here when the select is 1, then y is a meaning 1, and else part y is 0. So it cannot determine whether it is 1 or 0. So whether we apply compute as ternary or forward only x, it will return the x value only. Okay, yeah, thank you for watching this video. I hope I made it clear with these two modes with the X propagation.